YouTube is flooded with videos about reliable engines. And look, some of that info is solid, but here's the reality. A bulletproof engine doesn't mean a thing if it's mated to a transmission that's a total headache. A bad gearbox will kill a good car every single time. That's why we're breaking down the complete package today. The 7 best powertrain combos from the last decade with proven real-world durability. 5 Japanese icons, 2 American workhorses, and all of them guaranteed to outlast almost anything else on the road in 2026. And we're kicking it off with this Toyota A25A FKS, equipped with a 2.5-liter dynamic force engine, is a terrific model that debuted with the TNGA platform back in 2018. And that change was more significant than most people realize, because Toyota was redesigning how everything works under the hood. And that includes how the engine and transmission interact. We'll start with the engine. It's a long stroke design with a stroke-to-bore ratio of approximately 1.2. That's a technical term, but here's what it really means for you as a driver. It generates torque earlier in the rev range. Not at high revs, where you rarely go, but at low revs where you actually drive. That translates to smoother acceleration, less effort when pulling away from a stop, and overall, more efficient performance in everyday driving conditions. And that's more important than just peak power figures, because peak figures don't tell you how a car performs in traffic. Now, let's combine that with a compression ratio of 13:1. That's high. Very high for a naturally aspirated engine in this class. And while high compression improves efficiency, it also increases heat and pressure inside the engine. If not properly controlled, it can lead to long-term wear, knocking, and instability. Toyota addressed that problem with the famous D4S system, dual injection, port and direct. And this is one of the things that sets this engine apart from many others in the same class, because direct injection alone creates a well-known problem over time: the infamous carbon buildup on the intake valves. It happens slowly, and by the time you notice it, it's already expensive to fix. But our friends at Toyota avoided that. The port injectors spray fuel onto the intake valves, keeping them clean. So instead of having to deal with carbon buildup later on, it never becomes a problem. That's preventative engineering. So let's move on to the transmission, the 8-speed direct shift, because this is where things get super interesting. The early versions from 2018 to 2021 received complaints. People began to notice jerky shifts, hesitation at low speeds, and inconsistent behavior when flooring the accelerator. And, of course, those complaints were real, but here's the key. It wasn't a hardware failure. It was the software, as ridiculous as that sounds. Toyota released Technical Service Bulletin TSB-0043-19, which recalibrated how the engine and transmission communicate with each other. This update adjusted shift timings, throttle response, and overall performance. And once that update is applied, what happens? Exactly. The transmission becomes smooth and predictable, and most importantly, reliable. So, when you're considering buying one of these, don't just test drive it and make assumptions. Make sure that update has been applied, because once that's done, what you get is an extremely well-balanced powertrain. Efficient, durable, and built with long-term ownership in mind. An excellent choice from ingenious Japanese engineers. With this model, we're talking about something entirely different. It's in a completely different league. The Toyota 2.5-liter hybrid combined with the eCVT is probably one of the most misunderstood systems on the market. That's because when people hear CVT, they immediately think of problems: belts, pulleys, slippage, wear and tear. But it's not like that, not even close. Toyota didn't improve the traditional CVT design, it completely replaced it. This system uses a power split device with planetary gears. Everything is permanently engaged. There are no belts, no pulleys, and no friction-based components that constantly wear down under load. They've completely eliminated the point of failure, and that changes everything. Now we add MG1 and MG2, the motor generators. Here's how they work. When you accelerate from a standstill, when the load on the system is at its peak, the electric motors handle that load, not your combustion engine. That means your combustion engine avoids the most demanding part of operation every time you drive. And over time, that adds up. Less strain, less wear, longer lifespan. And this, we've seen it with actual data. Well, just look outside at taxi fleets, ride-sharing vehicles, and urban traffic. There they are. Why? Well, exactly for that reason. Normally, vehicles that reach 500,000, even 600,000 miles with their original powertrains. That doesn't happen by chance. That's what happens when friction-related failure points are eliminated and the load is distributed intelligently. This is one of the most durable systems ever built for mass-market vehicles. Another Toyota star. Mazda took a different path. While everyone else was downsizing engines and adding turbochargers, Mazda stuck with a naturally aspirated 2.5-liter engine. And that decision matters. Because turbocharged engines generate heat, pressure, and complexity. Mazda was very smart and avoided all that. Instead, it focused on efficiency through design. A compression ratio of 13:1. Again, very high actually. But they managed it using a 4:1 exhaust manifold, which prevents hot exhaust gases from re-entering the cylinder. That keeps combustion stable. That reduces thermal stress. And believe me, that protects the engine in the long run. Now the transmission, the 6-speed Skyactiv drive. This is where Mazda really shows its smarts. It uses a torque converter, but it locks up early and stays locked under most driving conditions. That reduces slippage, and slippage generates heat. Logically, heat causes wear. So by reducing slippage, they reduce wear. And that's why this transmission holds up so well over time. It feels direct, almost like a manual. But most importantly, it lasts. Here it's clear that the Japanese know how to fix mistakes. Let's talk about Honda now. Because if you've been around the automotive world long enough, especially if you remember the 90s, you already know what the name K-Series means. You could say these engines were legendary. Why? Well, they refused to die. And this 2.0-liter K20, it maintains that same philosophy, but adapted to a modern platform. Now is when you need to pay attention, because Honda offers you two different paths these days. There's the 1.5-liter turbo, and then there's the naturally aspirated 2.0. So, what about long-term reliability? The 2.0 is the safest bet, without a doubt, because the turbo engine brought problems with it. Oil dilution, issues with the head gasket, increased thermal stress. Let's just say it's a more complex system, and complexity always means more potential points of failure. The 2.0 avoids all that. No turbocharger, no forced induction, no additional heat introduced into the system. It's a simple engine that does exactly what it was designed to do, run consistently over time. And that matters more than people realize. Because, well, predictable thermal behavior means predictable wear and tear. And predictable wear and tear means greater durability. Now let's talk about the transmission. Yes, it's a CVT, and that's where people might start to feel a little uneasy. Because CVTs, as a category, don't have the best reputation. And honestly, that reputation isn't undeserved, let's be honest. But here's the difference. Honda didn't just install a CVT and leave it at that. They tuned it. They programmed a shift logic so it behaves more like a traditional automatic. So instead of that rubber band feeling where the engine revs but the car doesn't react, you get simulated gear shifts. That in itself improves the driving experience. But reliability comes down to something else: maintenance. And this is where most people get it wrong. This CVT needs fluid changes every 30,000 miles, not every 60,000, or worse, not whenever I remember. It's important that it's every 30,000, because that fluid is what protects the internal belt and pulleys. It manages heat, reduces friction, and keeps everything running smoothly. Do you maintain it? It lasts. Do you ignore it? It fails. And when it fails, it's not cheap. Those are the rules with this car. Take it or leave it. That's the trade-off. But here's the key. Fleet operators already get it. Urban fleets, ride-sharing drivers, delivery services, they all use these cars because they know what to expect. Simple maintenance, no turbo issues, and completely predictable costs. So, if you stick to the maintenance schedule, this setup offers something very similar to Honda's traditional reliability in a modern format. It's entirely up to you. Now let's move on to something completely different. Let's take a look at American engineering, but refined over time. The 5.0-liter Coyote V8. Here's the deal. This engine didn't have a perfect start. Earlier versions had some issues. They had oil consumption problems, noise from the camshaft phaser, inconsistencies that made people doubt its long-term reliability. And people realized it. But here's the crucial point. Ford didn't ignore it. They tackled it head-on. They updated the PCM to more effectively regulate oil pump pressure. This helped stabilize oil consumption. Then they introduced dual injectors, direct and port injection working together. The same concept we've seen with Toyota. Cleaner combustion, less carbon buildup, better long-term performance. And that's important because it's still a naturally aspirated V8. No turbochargers. Nothing forced into the system to introduce heat and pressure. Just a big displacement engine operating within its limits. And that's why it's working. Now let's talk about the transmission, the 10R80, because this is where things got tricky at first. The initial versions had problems, jerky shifts, inconsistent performance, and the main cause was the CDF drum. The internal movement of the sleeve caused instability during shifts, and when that happens, you can feel it. But again, Ford didn't ignore it. They redesigned it. Stronger materials, improved internal structure, greater control over fluid dynamics. And these changes weren't limited to software. They were physical improvements. That's why when we talk about after 2021, it matters, because that's when all those improvements came together. Before 2021, what can I say? There's nothing left to do but check it all out. Maintenance history, updates, performance. After 2021, you're dealing with a system that has been tested, refined, and corrected. And that's the big difference. It's not a propulsion system that was perfect from day one. It's one that has overcome real-world challenges and come out stronger. It's simple. This is a clear case of form taking a backseat to function. We have the GM 6.6-liter L8T, and right from the start, it's clear what this engine is all about. Cast iron block, valve system with push rods, no cylinder deactivation, no dynamic fuel management, no automatic start-stop system. And that's not because GM forgot to include those features, it's because they decided not to. Because those systems, especially cylinder deactivation, have caused serious problems in other GM engines. We had lifters failing, lubrication system complications, costly repairs. The L8T eliminates all that, thank God, completely. And that's what makes it reliable. Because fewer systems mean fewer points of failure. Now let's talk about the block itself, cast iron. And this is important in heavy-duty applications, because when towing, hauling, or working under load for long periods, heat becomes a major factor. Aluminum expands and contracts more with heat. Cast iron, it's stable. It handles thermal stress way better, and that's exactly what you want in a work truck. So let's talk about transmission options. There's the 6L90, tried and true, simple and widely used. And then there's the 10-speed Allison, newer with more gear ratios and better efficiency under load. Both have their place. Some fleet operators prefer the 6-speed because it's simple and predictable. Others opt for the 10-speed because it keeps the engine in its power band more efficiently while towing. But here's the thing. Both are built for the job. This isn't a powertrain for daily commutes. It's built to handle the stress, for the load, for long days and demanding conditions. And that's why it's a tank for work. Now we finish with something more refined. The Lexus RX 350. And this is where you see what happens when a powertrain reaches maturity. Because while the rest of the market moved towards smaller turbocharged engines, this stayed consistent. Naturally aspirated 3.5-liter V6. No turbo, no extra heat, no unnecessary complexity. And that alone gives it an advantage in long-term reliability. Now add the D4S system, port and direct injection working together. Same concept we've seen before. Prevent carbon buildup, maintain efficiency, protect the engine over time. But this engine also does something else. It can switch between the Otto cycle and the Atkinson cycle. That means it adjusts how it operates depending on demand. Performance when you need it, efficiency when you don't. And that flexibility reduces stress over time. Now the transmission. The Aisin 8-speed. This is one of the most proven automatic transmissions in the industry. Consistent, smooth, predictable. No surprises. And that's why reliability scores stay high. Because nothing here is experimental. Nothing here is rushed. Everything has been refined over time, and that's what makes this setup different. It's not just reliable, it's mature. And that's really the pattern you should be seeing here. The most reliable powertrains aren't the most complicated ones. They're the ones where the engine and transmission actually complement each other. Where stress is managed, not ignored. Where weak points are removed, not hidden behind software updates. Because in 2026, reliability isn't about one component, it's about the system. The full system. And if you get that wrong, you're buying a problem. And that problem turns into a ridiculous expense real fast.